Hello everybody, I'd like to introduce one of the types of the post hoc test, which is the Tukey's HSD test. HSD is the abbreviation of the honestly significant difference. This is one of the post hoc tests that is used in order to check for any significant difference between the means for two groups or more. This is the question that I will handle in order to compute and understand all the procedures for the Tukey's HSD procedure. What we have here in the middle, we have the one-way table, one-way Anova table, and all the needed records have been inside this table. And if we check for the value of the F statistic or the calculated F, it is 5.907, while for the critical value of F, it is 3.885. So we conclude that there is a significant difference between the means, and we need to know or to verify which two means, the difference between these two means are significant or not. So this is the purpose of the post hoc test, in order to determine the significance or non-significance between the means of the groups. So what is needed in our question? We need to conduct the Tukey HSD test or procedure to determine the significant status between the three means. The significant level is 0.05. Below we have the three groups. We have group A and group B and group C. And we already calculate the value of the mean for each of these three groups. For group A, it's 8.4, while for B, it's 10.2, while for C, it's 11.4. Regarding the sample size, it is 5 for all the three groups. Notice that the Tukey HSD test, it's only used in case of the sample sizes are the same. Otherwise, we can't use it. So let's start calculating the value of the Tukey HSD. Because we have three groups, group A and B and C, we have three pairs of means. We have first the means or the means between group A and group B, and we need to calculate the absolute difference between these two means. So the value of the absolute mean difference between mean A and mean B, mean A is x1 bar and mean 2 or mean group B is x2 bar. So the absolute difference is 8.4 minus 10.2, and the absolute value of minus 1.8, it is positive 1.8. So 1.8 is the absolute difference between group A and the group B. Regarding the second pair of means between group A and group C, the same procedure. The absolute mean difference between these two means is equal to the absolute value of the x1 bar, which is the mean of group A, minus x3 bar, the mean of the group C. For group A, it's 8.4, as we can see from the above table. And regarding the group C, the mean is 11.4, so the absolute difference is 3. Same for group B and group C, the absolute value, x2 bar minus x3 bar. x2 bar is the mean for group B, which is 10.2, while for x3 bar, it is the mean for group C, which is 11.4. So the absolute value of minus 1.2 is positive 1.2. What is needed from this question? We need to check whether this difference between a pairs of mean are significant or not significant. If the difference between the two means is greater than the value which will we get for Tukey HSD, we say that there is significant difference between these two means. Otherwise, if the difference between the two means is less than the value of the Tukey's HSD, so we conclude that there is no significant difference between the two means. So let's start calculate the value of the Tukey HSD. Here below, this is the formula for calculating the value of the HSD for Tukey's test. In order to calculate the value of the HSD for Tukey, we need to determine three things. First of all, we need to find the value of Q. It's called studentized range distribution. And we need three things in order to determine this value of Q. We need to determine the value of alpha, which is already known. It is 0.05 for our question. The second is the value of K, and the value of K is the level of the treatment. And in our question, we have three groups, so K is equal 3. And the third one is capital N minus K. Capital N means the total sample sizes for all the three groups. And K, as we said, it is the number of the groups or the level of the variable we are discussing. So this is the first thing we should determine. It is Q. The other thing is the mean square of the error. And this is simply, we can get it from the one-way Anova table. And this value is equal to 1.93. And the third thing we should know is the value N. N is the sample size for one group, because the three groups are of the same sample size. So first, we will determine the value of Q, the studentized range from the distribution for this value. This is the table in order to determine the value of Q. The value of alpha is equal to 0.05. This row here represents the value of K, and K means the level of the variable we are discussing, we have three groups. So the value of k for our question is 3. Regarding this column is the value of the capital N minus k. Capital N minus k, it's the same as the degree of freedom for the error. If we return back to the one-way Anova table, if we check for the degree of freedom for the error, it is 12. And the value 12 is got by capital N, which is 15, minus k, which is 3. So the difference is 12. So the intersection between k equal 3 and degree of freedom equal 12 is 3.773. So this is the value of the studentized range Q at 0.05 and k equal 3 and capital N minus k, or the degree of freedom for the error, which is equal 12. It's equal to 3.773. And by rounding this value into 2 digits, we get the value of Q to be 3.77. So we have got the value of Q. What is needed now is the value of MSE, mean square of the error, which is 1.93. It's from the one-way Anova table, while N is the sample size for one of the three groups. It is 5. And the value of Q, it's already determined. So if we substitute, the value of HSD is equal 3.77, which is the value of Q, 1.93, it is the mean square of the error, and 5 is the sample size for one of the three groups. If we proceed, we get the value of the Tukey HSD to be 2.34. This is the value of the HSD. And we count for the HSD only one time. Now we can compare the absolute differences between each two means with the value of the HSD. So the value of HSD, it's equal to 2.34. Regarding group A versus group B, we already calculated the value of the absolute difference. It is 1.8, and 1.8 is less than the value of HSD, which is 2.34. So we conclude that there is no significant difference between the mean of group A and the mean of group B, which means simply that X bar A is the same as X bar B, which means that the mean for the population A is the same as the mean of population B regarding the variable we are interested in. Regarding group A versus group C, the same procedure. The absolute mean difference is equal to 3, and 3 is greater than the value of HSD, which is 2.34. So there is a significant difference between the mean of group A and the mean of group C. which means that the two means are not the same. X bar A does not equal to X bar C. Which one is the bigger? We return back to the table in the above. If we check for the mean for group A, it's 8.4, while for group C, it is bigger, it's 11.4. So X bar A is less than X bar C, or X bar C is greater than X bar A. The same procedure for group B and group C. The absolute difference between the two means is 1.2, and 1.2 again, it is less than the value of HSD, which is 2.34. So we conclude that there is no significant difference between the two values, which means that the mean for group B is the same as the mean for group C. So X bar B is the same as X bar C. And we can say that the population mean for B is the same as the population C regarding the variable we are interested in. So here, this slide summarizes the result we have got. We have three groups pair, A versus B, and A versus C, and B versus C. A versus B, the difference between the two means is 1.8, and the value of the HSD is equal to 2.34. So there is no significant difference between the two means. Regarding groups A and C, the difference is 3, and 3 is greater than the value of the Tukey HSD, which is equal to 2.34. So we conclude that there is a significant difference between the two means. Regarding the pair B versus C, the absolute difference is 1.2, and 1.2 is less than the value of the Tukey HSD, which is 2.34. So there is no significant difference between these two means. So this is the way how to calculate the value of HSD and make a conclusion regarding the means, which means has significant and which means doesn't have any significant. So in order to make a summary regarding the Tukey HSD, we say that Tukey HSD, it's very simple in calculation. As we have said, we need three values in order to determine the value of HSD. But the limitation for the Tukey HSD is that the sample sizes should be equal, should be the same. If they are not the same, we use another test which is called Tukey-Kramer test. One of the main benefits of the Tukey HSD is that the test or the HSD control the value of alpha type 1 error. So it is considered as a conservative test. That's all. Thank you. If you have any comments, please write it down. Thank you.